The REXA actuator interface with the plant's control system is the local control enclosure. The control enclosure receives a position signal and provides a position feedback to the plant's control system. Its other function is to position the valve as required by providing a drive signal to the actuator power module, based on the position signal from the plant's control system compared to position feedback from the actuator's cylinder. The REXA actuator is a closed-loop hydraulic system. It consists of the hydraulic cylinder, the power module, and the feedback module. The rotary and drive actuator provides a 90-degree movement for use in ball valves, butterfly valves, or dampers with linkage. The attached valve or drive arm will be connected to a pinion, which is turned by a single or multiple racks. Hydraulic pressure at the ends of the rack will provide the movement. Each end of the rack is identical in size, ensuring the same volume of oil is moved by the pump to either side to position, eliminating the need for any extra oil storage. The feedback module contains a potentiometer connected to the pinion. As the pinion rotates, it will also rotate the potentiometer, adjusting the signal from this device, which represents the position of the valve. The power module is the main component of the actuator. It contains the motor, gear-type hydraulic pump, and the flow match valve assembly. The pump motor is a 100% duty reversible unit which drives the internal hydraulic pump. The motor is either stepper or servo. These motors are used because their speed and direction can be precisely adjusted by the position control module to meet the performance required. The motor only activates when a valve position change is required, making it highly efficient. The hydraulic pump only generates the pressure required to overcome the load that the actuator is driving, making it even more efficient. The flow match valves are a unique pilot check valve flow control type design. The design allows for a constant oil volume to be moved back and forth from one side of a double-acting cylinder to the other. This happens in a smooth and stable manner regardless of the applied load or any load variations, including bidirectional dynamic loads from zero load to full actuator output. Unlike servo and proportional valves, the flow match valve does not require a constant pressure to be supplied to it, so continuously running motors, pumps, or accumulators are not required to maintain the valve position. The main parts of the valve are the spool and check valve assembly. Each valve provides alignment of multiple sets of ports for proper operation. In this instance, the main valve is required to close, the hydraulic pump will start, simultaneously supplying the bottom chamber as it draws from the top chamber. The top chamber is the supply for the bottom chamber and vice versa, when the pump direction changes. The pump will displace the oil, simultaneously lifting the flow match valve spools and aligning the ports, depending on the direction of the rotation of the pump. The actuator will move the connected valve in the direction that the cylinder drives it based on from or to which side of the cylinder oil is being transferred. Once the valve reaches the desired position, the pump will stop, flow match valves will return to their normal position, and the valve actuator will be locked in its current position. If the valve was required to move in the other direction, the pump motor will start in the reverse direction, causing the flow circuit to reverse in the mirror image. The actuator will move the connected valve in the opposite direction. Once the valves reach the desired position, the pump will stop, flow match valves will return to their normal position, and the valve actuator will be locked in its current position.